Hello students, how are you all? I hope you all are doing well. Welcome to you all on our channel. So in our today's video, we are going to learn one of the very important topic from trigonometric function chapter, which is the sine rule. Very important topic. Every exam that rule it is coming. So already you have seen previous year question paper already, plenty of the question which based on sine rule it is coming. So there are some other rules as well, like cosine rule, projection rule. You all have seen these rules. But in our today's lecture, our main target is that to understand sine rule in detail. And along with the sine rule, I plan to add one more topic here, which is the Cartesian and polar coordinate. Okay. So under Cartesian and polar coordinate, we'll understand first of all x and the value for x and the value for y. Okay, x which is equal to r cos theta, y which is equal to r sin theta. These are the Cartesian coordinate and polar coordinate for our xy plane. Okay, so we'll go through that topic first and then we'll move for the sine rule. Okay, so keep in our mind that our main target is for this lecture it is only the sine rule. So if you are interested to see similar video, you may check into my channel, so you will get the similar videos on our channel. Okay, so in our previous lecture we have uploaded general solution and particular solution for trigonometric function. Every year there are some specific amount of the question which is coming on general solution, principal solution. Now in our today's lecture we'll understand only the sine rule and along with the Cartesian and polar coordinate. So we'll go for some of the example which based on these topics. Okay, now let's get started. So here, first of all, we have to understand what is the Cartesian coordinate and polar coordinate. To understand these topics, we'll see first of all the Cartesian coordinate. What is the mean by actual meaning for Cartesian and polar coordinate? If we see Cartesian coordinate, the value is which look like x and y. Okay, the value which comes from x come from y, we consider it as the Cartesian coordinate. So meaning for it, we have the value for when we have the value for x and y form. When we have the value, it will form of x and y. So we consider it as the Cartesian. Cartesian coordinate. Okay. Okay, so we consider it is the Cartesian coordinate, and when we have the value like r and theta form, like r theta, we consider it as the polar coordinate. Okay, so I hope you all have understood what is the how Cartesian coordinate look like and how polar coordinate look like. Okay, so in your exam will be given like x and y, the value for x and y, then you have to find out the value for r and the theta. You have to find out the value for r and theta, and if you have given x and y, so if you have given r and theta, then find out x and y, and if you have given x and y, then find out r and theta. That means that question, it comes for your board exam, it's like a 3 to 4 marks question. Okay, very easy question, just need to apply one basic result, easily you will get the answer. Now here we can see we have the value for x and y. So how can we define x, y, r, theta in our coordinate axis? Okay, so to define these values, we have to observe coordinate axis. Now here we can see we have x coordinate, we have y coordinate. Okay, so we have x coordinate on our x-axis, y coordinate on our y-axis. So by using x and y coordinate, try to draw one triangle. Okay, so I have one triangle here. So using theta, I drew one triangle here. So if we take x-axis, that means the value for x which is coming from x-axis. If we take y-axis, that means the value for y which comes from the y-axis. Okay, so y which is from y-axis, this y which is from y-axis, and this x is already there in a x-axis. Okay, so we don't have specific value for x and y. So in general, I consider it as a small x and small y. Okay, so here we can see this one is the small y from this side, this one is the x for this side. Okay, and this is the hypotenuse which is the r. Okay, hypotenuse r, it is there. So using this, we have to define Cartesian and polar coordinate, and already we are familiar with that. Cartesian and polar coordinate are having form like a cos theta and sine theta. Okay, these are the form for Cartesian and polar coordinate. We'll use this one here further. So how cos theta and sine theta we can define here on our theta? So here we can see cos theta we want here and sine theta we want here. Okay, for finding cos theta and sine theta. So as we know that sine theta, it can be defined as opposite side for our triangle upon hypotenuse. It is for sine theta. And when we want cos theta, we take adjacent side upon hypotenuse. Okay, so how we define opposite and adjacent for our triangle? Now here we can see the biggest side from our triangle, which always goes to hypotenuse. Okay, we all are familiar with this. Now we want the opposite side for theta. So opposite side for theta means front side of that theta. Okay, so front side, what it is the front side? That it is PM is the front side for our theta, so which is the opposite side, and PO, which is the hypotenuse for our triangle. Okay, so it is the hypotenuse, it is the opposite side for this theta, and the remaining side, the leftover side, which is from our triangle, which goes for adjacent side. Okay, so only we have to define three sides: one adjacent, opposite, and hypotenuse. Okay, so I hope you all have understood the meaning for opposite side, adjacent side, and hypotenuse side. Okay, so using this, define sine theta now. Tell me the value for sine theta, which comes as the opposite side, PM. Okay, very good. PM is opposite side. Very good. And then hypotenuse. So which is the hypotenuse? Sir, PO is the hypotenuse. Very good. PO also hypotenuse. Similarly, do it for cos theta. What is the adjacent side? Now, how we define cos theta? Which is the adjacent side upon hypotenuse. Okay, which is the adjacent side? OM. Yes, sir. OM is the adjacent side. Very good. Now we want the hypotenuse. Now PO. Okay, OP, it is the hypotenuse over here. Okay, or PO is the hypotenuse here. Now substitute all value. What is the value for PM? PM, which is Y here. Very good. Now PO we want here. PO, which is R here. Very good. Okay, R, we consider R as a PO. The value for R, it is a PO here. Okay, and similarly for cos theta, do it. OM we consider here X, and a PO we have here R. Okay, that means we got the value for sine theta, which is a X divided by R, and a cos theta, which is a sine theta, which is a Y divided by R, and a cos theta, which is a X divided by R. Now this is the main time to define Cartesian and polar coordinate over here using this result. So what we do, take R here, so we'll get the R sine theta, R sine theta, which is equal to Y, and we'll get the next value, R cos theta, which is equal to X. Okay, so these are the two value which we have here for X and Y. So what we want here, we want the Cartesian coordinate. That means we want the value for X and we want the value for Y. Okay, the value for X, okay, and the value for Y, which together represent Cartesian coordinate. Okay, the value of X and Y together represent Cartesian coordinate, and when we take R and theta together, then it represent polar coordinate. Yes, is it representing? Yes, sir, it is representing Cartesian and polar coordinate. I hope that you all have understood the difference between Cartesian coordinate and polar coordinate. So we have to apply Cartesian coordinate and polar coordinate for solving our examples. Okay, let's get start our one of the example which based on Cartesian coordinate and polar coordinate. Okay, we'll solve one of the example, just only one example, because it is just only the substitution of value, so we are not going in detail. Okay, so remaining example you have to try by yourself. So here I consider one example here, the Cartesian coordinate. Okay, we have to find Cartesian coordinate whose polar coordinate given. Okay, so polar coordinate given, that means we have given the value for R, radius R, and the theta, which is a pi by 4. So what we have here, radius R, which is equal to 2, and theta, what we have here, pi by 4. Okay, so whenever you have polar coordinate, always remember that coordinate goes to R and theta. That means radius 2 and polar that means radius 2 and theta is here pi by 4. So what we want here, the Cartesian coordinate. So whenever Cartesian coordinate it comes front of you, so what we want here, the value for x and y. That means value for x which is equal to r cos theta and y which is equal to r sine theta. Okay, so apply these two values here for finding the value for x and y. Now substitute the value for r and theta. So what we will get, x is equal to r cos theta, that means 2 times cos theta, cos of pi by 4, 2 times cos of pi by 4, and y which is equal to 2 times sine of pi by 4. Okay, so what I have done, I just substitute that value for theta pi by 4 here, because theta it is the same for sine and cos. Okay, we have same theta here which is a pi by 4. Now substitute that theta here and you will get the answer. Okay, radii which is given to, so what is the value for cos pi by 4 and sine pi by 4? This is the angle pi by 4 which is a 45 degree, which gives the same value for sine as well as cos, which is a 1 by root 2. Very good. So we got the 2 multiplied by 1 by root 2. Similarly here 2 multiplied by 1 by root 2. So what is our answer here? 2 by root 2 here. Okay, so here it is also 2 by root 2. Okay, so we want the simplified form. If you want, you can go for further and find out simplified form for our solution, or you may keep that solution as it is. It is completely up to you all. Okay, but as I felt that we have to go little simplified form of our solution. Okay, so 2 by root 2, how can we solve? 2 divided by root 2. So what I'm going to do here, I will multiply root 2 at the numerator and denominator as well. Okay, so multiply root 2 divide root 2, our quantity it will remain same. Okay, 2 multiplied by root 2 keep as it is, and complete divided by root 2 into root 2. When we multiply 2 times root 2, so we'll get the 2. Okay, that means how we write 2 multiplied by 2. Okay, when we multiply 2 multiplied by 2, it goes to square. Okay, that means root 2 multiplied by root 2, how we write? Root 2 square. Okay, that means we'll get the 2. Okay, square get cancelled with the square root, so we'll get the 2 here. So that 2 cancel, will left with the term root 2. Okay, I hope you all have understood how I have written root 2. Okay, so here the value it comes root 2, and here it is also coming root 2. Okay, so when we have radii and angle theta given, using that you can easily find out the value for x and y, which is the root 2 and root 2. Okay, so here we can see root 2, which is the Cartesian coordinate, which is in the form of x and y. This is our required answer. Okay, I hope you all have understood my solution, that we want the Cartesian coordinate from our polar coordinate. Okay, so these are the polar coordinate given, so you have to find out that the Cartesian coordinate. Okay, I'm expecting that you all have understood this one. And similar vice versa, if you have given Cartesian coordinate, that means if you have given the value for x, y, and if you want the value for r and theta, I'm not going to I'm not going to use any example here to explain this topic. You have to understand by yourself. Okay, so if you have x, y, and if you want the r and theta, so what you do, you need to find a radius and theta. For finding the value of a theta, we use this result, but for finding the radii, we use square root of x square plus y square. We use this result. Okay, for finding the value of a radii. So using that radii, substitute that radii here, y here, x here, and then you will get the value for theta. Now see that how easy it is to find out the value for polar coordinate and Cartesian coordinate. Okay, I'm expecting that you all have understood the Cartesian coordinate and polar coordinate for our theta. Okay, so our main topic for our today, which is the sine rule, that we all are waiting for that rule from long. Okay, so let's get started our rule. I will explain to you all in detail how sine rule coming and how easy it is. It is very much important rule used everywhere in our mathematics, so we are going to use that rule here. Okay, first of all we'll explain how the sine rule looks like and how we can prove this one. Every year board exam, that question comes to our board exam. Okay, uh, for sine rule. So after that sine rule, we have cosine rule as well as projection rule. Okay, so we are going to learn these rules as well. But before that, first of all, we will go for sine rule. So if you want the solution of trigonometric functions, so if you want this video, you may check into my channel. You will get these videos. Okay, so you can see this video because these questions are very much important for your board exam. Surely 2 or 3 questions coming for your board exam. Okay, see this video if you want. Okay, let's move for the proof of our solution sine rule. Okay, but why we are learning that sine rule, cosine rule, projection rule? So if you have to find out the value for theta or value for sides, okay, that means value for side C, value for side A, value for side B, or angle A, angle B, angle C, that time we use a solution for finding the solution of a triangle. We use sine rule, cosine rule, and projection rule. Okay, so our today's lecture, it is completely goes for sine rule. Okay, now let's start the proof of our sine rule. Okay, so I will explain the proof of sine rule here. Okay, now here in a triangle ABC, we have to prove A upon sine A, B upon sine B, which is equal to C upon sine C, which is equal to 2R. Okay, so we have to prove this rule. Here R is the circumradius of a triangle ABC. So what is mean by circumradius? Under circle, if we get the any kind of a triangle, so for that triangle we consider it as the circumradius. Okay, so we'll see that circumradius later on. So first of all, we'll prove the proof of sine rule. Okay, so we'll go for the proof of sine rule first, and then next part we use the circumradius for finding the complete proof of A upon sine A, B upon sine B, C upon sine C, which is equal to 2R. Thereafter we have some of the different form of a sine rule. Okay, and now let's consider triangle ABC. Okay, so here we have triangle ABC. So we'll consider triangle ABC first. Okay, in triangle ABC, okay, I have considered one triangle which is a triangle ABC. So using that triangle, what we do, first of all, we use some separate angle A, angle B, and angle C. Okay, we use angle A, angle B, and angle C, and then we'll find out the value for these angles. Okay, now before starting our proof, I wanted to prove one result of area of a triangle. So as we know that area of a triangle ABC, we can write 1/2 into base into height, this base into this height. Okay, so base what we have here, BC is a base, into height it is AD. Okay, AD it is the height. So 1/2 keep as it is, put the value for BC. BC I substitute the value for BC is the A, into AD it is here. Okay, so area of a triangle ABC, we have 1/2 A into AD. Okay, so this is the area of a triangle ABC. So I got the area of a triangle ABC. So using that result, we'll go for the complete proof. Okay, using that result, we go for the complete proof. So first of all, what we do, apply the sine rule for B, angle B, and angle C. Okay, so what we have the sine rule. So sine rule, it says that opposite side for that particular angle which divided by hypotenuse. Okay, so what is the opposite side for angle B, which is the front side? Okay, front side of angle B, which is the opposite side. Okay, so we use the sine rule for angle B, which is the sine B. Sine B, it is coming as opposite side, which is the AD, which is AD completely divided by then hypotenuse. What is the hypotenuse here? AB. Okay, so that means the biggest side for our triangle, which is a hypotenuse, front side, it goes to opposite side. Okay, that means we have hypotenuse AB. So what is the value for AB? And we have the value for AB here as well. Okay, so substitute the value for AB. What we have? C. So AD upon C. Okay, so we'll get the AD upon C. Now transfer that C, take that C to this side. So we'll get the C sine B, we'll get the C sine B, which is equal to AD. Okay, so I got the value for AD, which is equal to C sine B. Okay, so that B, it is capital. Okay, capital A, capital B, capital C are the angles of a triangle, and small a, small b, small c are the sides of a triangle. Okay, So using sine B, I found AD which is equal to C sine B. Okay. Again, use the result for angle C. What will get the sine C? Sine C, we can write sine C. That means opposite side AD upon opposite side AD upon hypotenuse. Hypotenuse, what is the hypotenuse? Biggest side for our triangle. So we have biggest side here, angle AC. Okay, side AC. So we get the side AC. That sine B we consider for ABD, triangle ABD. We use a triangle ABD for this result, and now we use angle ADC, triangle ADC for this result. Okay, so we use two separate result to prove two separate values for sine. Okay, so using that to put the value for AD and AC. So we don't have any value for AD. Now substitute the value for AC. Now we can see that AC which is equal to small b. Okay. Now transfer this value over here. So we'll get the b sine C which is equal to AD. So we have second value, okay, b sine C which is equal to AD. Now what we do, we substitute two of these values in our area of a triangle ABC. So as we have area of a triangle ABC as 1/2 A into AD. So instead of AD, substitute these two values. So you will get the required area of a triangle. So what is the first area of a triangle? Using first value, okay. So consider this first, take it as a second, okay. So using first, what do we do? Substitute these values here. Area of a triangle ABC will get the 1/2 into BC into AD. That means 1/2 A into ED. So instead of AD, substitute that first value C sine B. Okay, C sine B. So using first, we got this one. So using second, let's go for the using second area of a triangle ABC. We can write 1/2 into A as it is, the value for AD. Now substitute the second value for AD, which is a B sine C. Okay, now here we can see that this one and this one are the two area of a triangle for the same triangle. Okay, now it is remaining for angle A. Okay, so you do it by yourself for angle A. I'm going to write it directly here because it is the same proof like remaining one. So using don't need to write using any other thing. So area of a triangle ABC, I can write it as the 1/2. Now we can see here AB, it is there C, AC there, it is a B. So remaining, how can we write A, B, C, it is there now. So what we have here, AC done. After that AB done, remaining it is here BC. Okay, so 1/2 it is equal to B into C into, so when we have B, there is AC, C there is AB, and BC, then we write sine A. Okay, I hope you all have understood this one. Okay, now here we can see that this result is for area of a triangle ABC, this one is for area of a triangle ABC, and this one it is for the area of a triangle ABC. That means these three values are equal to each other. Okay, because these are the area of a triangle for same triangle. Okay, that's why we are taking it equal. So how can we write this one? 1/2 AC sine B, which is equal to 1/2 AB sine C, 1/2 small a small b sine C, which is equal to 1/2 BC sine A. Okay, so this is the required step. We found it here. So as we have 1/2 everywhere same, we can cancel this one with this one. Okay, so we cancel 1/2 from each of the side. Okay, so the remaining side here, AC sine B, AB sine C, and BC sine A. Okay, so here we can see AC it is there, again BC, AB it is there, and BC it is there. So we do not want this term. Okay, along with the sine B, sine C, and sine A. So that's why what we do, we divide throughout by ABC. So divide throughout by ABC, here ABC divide, here ABC divide, and here I divided by ABC. Okay, Now here we can, it seems like that the denominator it is having AC value, numerator also having AC. So cancel same term here as well as here. So what we'll get? Sine capital B upon small b, which is equal to, similarly cancel AB with the AB, sine capital C upon small c, which is equal to, cancel that BC here with the BC, sine capital A upon small a. Okay. So this is the division for two constant number. Okay. Why sine B is constant? If I substitute any value under sine, that means sine, if I consider 45 degrees, so we'll get the 1 by root 2. Okay. That means this is some sort of a constant value. Okay. That means some constant divided by a. What is a? It is side length of a side. That means it is also constant. So constant divided by constant will get something constant. Okay. So here we have constant k. So this is the proof for sine rule. So in your board exam, if you get the question, prove sine rule for the value of k. Okay, then you have to prove till here only. Okay, so this is the complete proof for sine rule, which asks for 4 marks. Very much important. Do it, because this time a similar type of the proofs are coming for your board exam. Okay, so I'm expecting that you all have understood this one, but the hold on, proof it is not finished here. Okay, the remaining part it is still remaining. So we have to prove which is equal to 2r. Its right side we have to prove is a 2r. Okay, so we have proved here as a k. Now let's prove the remaining side as a 2r. Now what is the r here? R as a circumradius. I will explain to you all how r means here. Okay, so let's start our proof for 2r. So we have to prove the other side for that sine rule, which is the 2 times r. R it is here the circumradius for our triangle. What is mean by circumradius? Whenever we take triangle, circle, inside circle, if we take any triangle, the radius which passes from that triangle, we consider it as the circumradius for our triangle. Okay, now we can see that here we have the radius, 2 times radius. Okay, 2 times radius which passes from our triangle, we consider it as the circumradius. Okay, now before start our the proof for next part, so I would like to explain here the angle B for this triangle ABC. Okay, ABC for triangle ABC and triangle APC. We have the two triangle here. Okay, triangle ABC and triangle APC. We have two triangles here, triangle ABC and triangle APC, two separate triangle. So triangle ABC and APC, it represent here ABC, which angle B, and APC which represent angle P. Okay, so these are the two angle we have here, and now we can see that angle ABC contain arc AC. Okay, angle ABC contain arc AC and angle APC contain arc AC. Arc AC. Okay, that means these two angles are inscribed angle for our two triangles, and whenever under circle we get the two inscribed angle, that means these two angles are equal. Okay, that means angle B and angle P both are equal. That means we have angle B which is equal to angle P. Okay, understood how we get the angle B and angle P equal? Because these are the inscribed angle, and inscribed angle always equal. Okay, now as we are proving sine rule here, so apply sine rule to the both side. Okay, so we'll get the sine B which is equal to sine P. Okay, sine B which is equal to sine P. That means the angle which is coming from B and the angle which is coming from P, when we apply sine to both of them, we will get the equal answer. Okay, so it is the equal answer for both of them. Okay, I hope you all have understood this one. Now what we do, we'll apply the sine rule for angle B and angle P. Okay, as we have angle B and angle P, they are equal because they are inscribed angle. So what we do, we can find only one angle that using sine rule, remaining one we'll consider the it is equal for that one. Okay, so angle B and angle P are equal. That means we use a sine rule for angle P. Why we are using for only P, not for B? Because to consider hypotenuse adjacent for angle B, it is quite difficult. For that we use angle P. Okay, so sine of angle P, what we will get? Opposite side, which is the AC. Very good. upon hypotenuse, which is the AP. Very good. So what is the value for AC, which is a B, and AP, which is a 2 times radii? Okay. So we have sine P, which is equal to B upon 2R. Okay. But what is the value for sine P, which is a sine B here? Okay. So sine B, which is equal to what we have? B upon 2R. B upon 2R. What I have done, I substitute the value for sine P, which is a B upon 2R here instead of a sine P. Okay. So what we do, take sine B here, 2R here. So we'll get the 2R, which is equal to B upon sine capital B. Okay. So this is the value for B upon sine B, which is equal to 2R. Now what we do, we substitute this value in our sine rule. So what we have sine rule, A upon sine capital A, okay, B upon, so let's write last C upon sine C, which is equal to B upon sine B, but which is equal to 2 times circumradii, okay, which is equal to 2 times circumradii we have here. Okay, so this is the 2 times circumradius it is here. So that means we have proved here the sine rule, which is equal to 2 times circumradii. Okay, I hope you all have understood that my proof for a sine rule. Okay, so this is the complete proof for our sine rule. So it is quite much easier. I'm expecting that you all have understood it in this proof here. Okay, so even after, if you have any doubt, difficulty, let me know in comment section. I will come up with the similar videos. Okay, now in my next part, we have to prove the different part of a sine rule. Okay, so the different part of a sine rule, we can see it here, that A upon sine A, B upon sine B, C upon sine C, which is equal to 2R. Already we have proved. Okay, then after that, A upon sine A, sine A upon A, sine B upon B, sine C upon C, which is equal to K. This one is also we have proved. After that, the second one, okay, second one we have to prove here. So A upon sine B, which is equal to 2R. What we have? A upon sine A, which is equal to 2 times radii. Okay, take sine A to the other side, we'll get the A, which is equal to sine A times 2R. Okay, now we can see that A, which is equal to sine A times 2R. Similarly, apply for B upon sine B, you will get the B, which is equal to 2R sine B, and for the C, C which is equal to 2R sine C. So you will get the separate result here for sine. Okay, all these results are equivalent and all are the rules for sine. Okay, these are the sine rule. Similarly, these 3 results you all have understood. Now for a third result, what we do, sine B into A, which is equal to B into sine A. B into sine A is equal to A into sine B. Now we can see that here, A into sine B, which is equal to B into sine A. Similarly, B into sine C, which is equal to C into sine B, and similarly A into sine C, which is equal to C into sine A. Okay, so this is the next proof here. And next part, we are taking only the ratio between these two trigonometric identities, like sine A upon sine B, which is equal to A upon B. Similarly, you can prove this identity over here. Okay, I hope that you all have understood my complete proof and different form of a sine rule. Okay, so with the different form of a sine rule, I would like to conclude my today's lecture over here. If you wanted to see similar video, you can check in our channel, so you will get the similar type of the proofs in our channel. Okay, and if you wanted to see previous video, it is also there in our channel. So thank you everyone. Thank you for my today's lecture. Thank you for attending my class. Thank you everyone.